How do JTAG and SWD help you debug embedded systems? Imagine working on a complex device where every second counts, and understanding what is happening inside the system can be the key to solving a tricky problem. Embedded systems are everywhere, from medical devices to automotive controls, and ensuring they operate correctly is crucial. To do this effectively, engineers relying on specialized tools and protocols that provide insight into the internal workings of these devices. Two of the most important interfaces used for debugging are the Joint Test Action Group interface and the Serial Wire Debug interface. The Joint Test Action Group interface, commonly known as JTAG, is a standardized protocol that allows direct access to the internal components of a microcontroller or digital device. It provides a means to communicate with the device's internal registers, memory, and logic through a dedicated set of pins. JTAG is especially powerful because it enables boundary scan testing, which allows engineers to test interconnections between integrated circuits without physical probes. This capability is invaluable for identifying manufacturing defects or connection issues. When debugging, JTAG allows developers to halt the processor, step through code line by line, and examine the contents of registers and memory locations. This level of access helps identify bugs that are difficult to reproduce or diagnose through high-level code alone. The Serial Wire Debug interface, often abbreviated as SWD, is a more streamlined alternative to traditional JTAG. It uses fewer pins, making it ideal for space-constrained embedded systems. SWD provides similar debugging capabilities, such as halting the processor, setting breakpoints, and inspecting memory and register contents. Because it requires fewer connections, SWD simplifies the hardware design and reduces cost, making it popular in modern microcontroller development. SWD also supports programming the device's firmware directly, which accelerates the development cycle. Both JTAG and SWD facilitate real-time debugging, allowing developers to observe system behavior as it happens. They enable firmware flashing, hardware testing, and troubleshooting without the need for external equipment or complex setups. By providing low-level access to the device, these interfaces help identify issues like memory corruption, timing problems, or incorrect register configurations. They are essential tools in the embedded systems engineer's toolkit, ensuring devices operate reliably and efficiently. In summary, JTAG and SWD are critical for understanding and troubleshooting embedded systems. They offer direct access to internal hardware, enabling detailed inspection, testing, and programming. Their use accelerates development, improves reliability, and helps engineers resolve complex issues that might otherwise remain hidden.